Okay, let us do 4.2 today. So, let me write down. Linear approximation and differentials. So we do linear approximation of a function a point. Okay, so we had equation of a tangent line, right? Before that, we know, let's see. Always start weird. So we know slope formula, which is y minus y sub 1 equal to m x minus x sub 1, right? Then f is differentiable at point x equal to a. Okay, then we said that slope of tangent line, right? Okay, then look, we have y minus f, y sub 1, and then we can express m slope of tangent line, which is f prime of a, right? X minus a. Then we want to express this one as function notation, because in this case, the order pair is a and f of a, right? So this will be y minus f of a equal to f prime of a, x minus a. Then look, we can move f of a other side. Then we have y equal to, they put the f of a in front instead of the n, and plus f prime of a and x minus a. Okay. So basically, we derive a formula, but we did this one before, right? Okay, it's the same as equation of a tangent line. Okay, look, let's see. We have function f of x equal to 1 over x. A equal to 2. Okay, then we know this is differentiable at a equal to 2, right? Then how will you get f prime of x? F prime of x?
Negative 1 over x squared.
Excellent. Then if we put the f prime of a, which is 2, what do you get this one?
Negative 1/4.
Which is negative 1/4. Good, right? Then look, what's the f of a? F of 2, which is 1 over 2, right? Then this will be y equal to f of a, which is 1/2 plus f prime of a, which is negative 1/4. And then x minus a equal to 2, right? Then we simplify this one and this one. Then normally we get the equation of a tangent line, right? Now, why we are doing this one? Okay. If we have linear, which is straight line, right? Then we can approximate the function at the point. Okay. So let me show you this one. When x equal to a, which is in this case a equal to 2, right? But what if we have f over 2.1? So what if x equal to 2.1? Then can you please calculate this one? Y equal to, I'm using from this one, 1/2 minus 1/4, 2.1 minus 2. Can you please calculate this? It's a 0.475. Okay. So this one we are using basically equation of a tangent line, right? This is come from, right? But then how about f of 2.1? So f in this case, f of x equal to 1 over x. So we do 1 over 2.1. So what do you get? Can you please calculate? So approximately 0.476. So can you take a look, the compare with the up there and then down there. So one is 0.475, one is 0.476. So this is it. The bottom one is actual value. We plug in 2.1 in that function, right? And then the above one, we derive, actually we are using the equation of tangent line, right? Then we substitute the 2.1, then we get 0.475, right? Which is very similar, right? So we said that this one, so I'm gonna change it y in this case. Oops. L over x. Then we name this one, naming linear approximation. Or other book indicate that approximation or tangent line approximation. Okay. So let us call it linear approximation because title said that. Okay. Linear approximation. So we approximate at the point. Okay. So let me draw this one, space there. So the function 1 over x Looks like that, right? Okay. And so f of x equal to 1 over x. We make a tangent line, equation over tangent at 2. So at 2 here, 2. And so yeah, like pretend to touch each other, okay? Yeah. All right. Let me erase this one. It must be the tangent line, okay? If we look for the approximate value, it's not nearby tangent line. For example, x equal to 10, a equal to 10 in this case, we get different value. It's not similar with actual value with the linear approximation there. Okay. So let me clear this one. 4.2. So let me write down. Find the linear approximation of f of x. So basically, we want to know about the value approximately and use the approximation to estimate square root of 9.0. Okay. All right, so I rewrite the formula, which is same as equation of tangent line, right? So we express nice way. So then a equal to 9 in this case. Okay, so f over a, right? Let me write down everything for you. So square root of x and plus, what's the f prime of x? What again? F prime of x? Someone said that.
1 over x squared.
1 over x squared? 1 over 2? Square root of.
Yeah. That.
Yeah. Okay. So thank you. So we have 1 over 2. Color. 1 over 2. Square root of x. And x minus a, right? this is in general, in this case. Now, square root of x, which is 9, plus, oh yeah, I should put the a, huh? So f of a, 2. So basically a, which is 9, x minus 9, okay? All right, so then we have a square root of 9, which is a 3, plus 2 times 3, which is 6, and x minus 9, right? It's okay? Now, we can just say from here, 9.1. Okay, so this is 3 plus 1 over 6 and 9.1. Now, your turn. Can you please calculate? What do you get this?
3.017.
So 3.1017. Okay, good. And then estimate square root of 9.1. So where's the function? So function you actually using calculator. And what do you get?
Also 3.017. It's almost the exact same number.
Okay. 166. Okay. So let me draw this one from book. So we know the square root of x looks like that, right? Then it's about 9 here. Then we make tangent line, which is here. Okay, it's about 9. Okay. Then we make approximate. It's 9.1 and very similar, right? Almost same as the actual value. Okay. We have a really nice number, nice function, which is square root of x, but there's crazy polynomial, and we want to approximate at the point, then we are using linear approximation because linear always easy to approximate, okay? All right, so let us do one more. Then other stuff. Let me erase. Open to her. Approximation. F of x equal to sine x and x equal to pi over 3. So later on, we're going to use this one as a, I erased the formula, huh? F of a plus f of prime of a, x minus a, right? Okay. Now, let us do derive the function f of a, which is sine a, right? Now, f prime of x, what do you get?
Cosine of pi over 3.
Cosine x, so let us do that. So it's a cosine pi over 3, right? Then x minus pi over 3. So what's the sine 3 pi over 3? Okay, let me give you a tip. I want, yeah. Okay, so I'm a right-handed person, so, right? So this one is pi over 6, this one is the pi over 4, this one is the pi over 3, right? And then the coordinate 1, 2, 3, 1, 2, 3, right? And then denominator is 2. And then we make a square root on the numerator. So square root of 1 is 1, square root of 2, square root of 3, square root of 1 is 1. And I'm waiting for labels like that, okay? So cosine corresponding x, sine corresponding y, right? So in this case, it's 1/2, right? I understand you don't remember, you forgot everything, that's fine. From now on, please remember, okay? All right, so cosine pi over 3, what do you get?
Square root of 3 over 2.
So plus square root of 3 over 2, and we get x minus pi over 3, right? Now we're gonna, where? Did I make a mistake?
No, we were saying sines 1/2, but it's just, they're switched, you know what I mean? Cosine of pi over 3 is 1/2, right?
Oh, did I make a mistake?
No, I mean, it's still the same answer, but well, no, it isn't actually, yeah.
Oh, actually,
Cosine of pi over 3 is 1/2, right?
Yes.
But you
Okay.
have 1/2 for sine of pi over 3 and square root of 3 over 2 for cosine of pi over 3.
Oh, yeah. Yes, right? So this is pi over 6, the first one, right? And pi over 3 is here, right? Okay, so sine pi over 3, which is that one. Thank you. Right? And then cosine pi over 3 is the 1/2. So I said right? But I screwed up here, right? Correct? Yeah. Okay, then let us approximate. Yeah. So let us approximate. What they want? They want 62 degree. Okay, they want approximate sine 62 degree, but we did as pi over 3. Okay, so pi over 3 radians is equivalent to 60 degree. So they want to approximate to 62 degree, okay? Then 62 degree, how do we convert? Does anyone remember from trig? Okay, so from now on, you won't forget. Excellent. So we times, okay, 180 degree in the bottom, and then pi, because we want to make the radians, right? So 180 degree corresponding the pi corresponding 180 degree here, okay? So degree, we simplify, and then 62 pi over 180, what do you get?
I think it's 31 pi over 90.
Good. All right. So we do approximate 31 pi over 90. So can you please calculate? Okay, since you guys take so long, let me use the, it's given information from the question. They want us approximate in 62 degree. So this one, I'm gonna use from book, so we don't waste the time, okay? So line start to 0. So this point at okay, so this line, which is we just found here, y equal to plus 1/2 x minus pi over 3. Okay, and this function is the sine x. We know that. Can I erase? That's correct. Okay. Every time it must be in the tangent line. What's a tangent line means we touch the point, right? Touch the graph. Okay. If we draw the tangent line, we want to know about the approximate. Maybe they say that pi over 3 is more than that, further than that, then that's not less accurate. Okay. Yeah. Good question. All right. So let us do differentials. So differentials. So basically we call dy dx called the differentials. We talk about this before. Differentials. And so the amount a function changes is a result of a small change in frequency. So if we have y equal to f over x, it's a differentiable function. Okay, and they denote this one is dy equal to f prime. Is the correct value. So dy equal to f prime of x dx. Then we've seen this one before. This will be dy over dx equal to f prime of x. We call this is Leibniz. It's hard to pronounce. Leibniz notation. Leibniz, right? Leibniz notation. Is it correct? Leibniz. Oh, it's very hard. Then look, we call dy dx is differential. Okay, I wrote down already. So differentials. Okay, so let us do this one. We call this is differential form. And then this is differential. There is one person picking my spelling, so I need to write them really well. Differential form. Okay. All right. So this one, we're gonna just follow for each of the following functions. Find dy and evaluate when x equal to 3 and dx equal to very small amount, okay, 0.3. All right, so we have y equal to x squared plus 2x, okay. Now, we want to find the dy, then we're gonna just using the formula here. The dy equal to, which is f prime of x. So what's the f prime of x? F prime of x? Two x plus 2, right? 2x plus 2 and dx. So dx will be 0.3, right? But then when x equal to 3, so we're gonna say 2 times 3. plus 2 and 0.3. Can you please calculate this one? I copy wrong. It's okay. What do you get? It's 2.4. So let us do this one. Second one, y equal to cosine x. So the y equal to f prime. So y prime, what do you get?
Negative sine x.
Negative sine x. And we're gonna times dx, which is when x equal to 3. Can you please calculate? And 0.3.
It's negative 0.0423.
Say one more time, please.
Negative 0.0423.
Okay, thank you so much. Okay, that is a very small change in values. Okay. All right, let me erase this one. All right. Okay, so we have delta y. So they indicate small amount. So we change it from, let me write down. If x changes from a to a plus dx, small amount, okay? So small amount. Then changing x in dx, okay? So in this case, dx is the same as delta x. So we read this one, delta x, right? Greek, in Greek. Okay, then like a science subject, we measure all the time, right? Then we make an error because we are human being, right? Then they called propagated error. So it's in error in measurement. So then they're using this formula, delta y, which is f of a plus dx minus f of a. Okay, so this is also, we make approximation. So propagated error. So to estimate error. Where error is in measurement. Okay, then this is the same as, let me just write down. This is the same as approximately L a plus dx minus and f of a. Okay, then embedded tutor, can you please take care of it? I'm just kidding. Error. Okay. Thank you. I'm just kidding. F prime of A dx. And this is dy. Okay. So let us use this formula. Let me save the space. So let me write down this one here. Estimate. Thank you. Okay, let me erase this. All right. Oops, sorry. I need to save the space. Always time consuming, space consuming. Right. Y equal to x squared plus 2x. Compute delta y equal to, I'm sorry, n dy. At x equal to 3, if dx equal to 0.1. Yeah, I copied wrong earlier. It should be 0.1, not the 0.3. Okay, so delta y, we're gonna use the formula here. Delta y. There is no f dx. Dx is same as delta x, change in x. In this case, it's 0.1. Yes, thank you. Okay, so I'm lost. We do delta y, right? So let's say this is f of a, which is x squared plus 2x. So let me see. Where you get f of, let me see. Same as that. So f prime of, let us find f prime of a. So let's say f of a. Okay, y prime. Let's say that's just y prime. So what do you get this one?
Um, 2x plus 2.
2x plus 2. X plus 2. And we have f of a. So let's say the a in this case, 3. So 3 plus dx, which is 0.1, and minus f of a, which is 3. And this is approximate. This is the last one, yes. So let me use in space. Then this is L. Then 3 plus 0.1, which is 3.1 minus f of a. Okay, then equal to, so what do you get? So we have the function 3.1 to the square plus 2, 3.1, okay, minus f over 3, which is plug in 3 squared, and plus 2 times 3. Can you please calculate this one?
I got 0.81 for the final answer.
Okay, and then dy, we had the formula earlier, f prime of x dx. So we have f prime of x, which is in this case 2x plus 2. And we get dx, which is 0.1. So we do when x equal to 3. So we have 2 times 3 times 2 and 0.1. Can you please calculate this one?
Point 0.8.
This is also 0.8? Okay, thank you. Yeah. So I think in this case, they want to compare of delta y with dy. They're not changing much, right? They don't have a difference much. Okay. So today we do last approximation, linear approximation, and differentials, and then also the what is called propagated error, delta y. Okay.